Hello, and thank you for joining us for this brief look at Zoom's exciting new feature, Native Room Controls. My name is Shane Springer. I'm a solutions architect for Zoom, and I'll be stepping you through this today, so follow along as we take a look at what we have in store. First up, what are Native Room Controls? Some of you may have gotten here because the link was forwarded to you, some of you may have come looking for the feature, but let's talk real quickly about what we're covering today. Zoom Native Room Controls are simple, affordable, and flexible. Simplicity from being uncomplicated and having limited controls to not be confusing. There's usually no training needed, and what you see is what you get. It's also affordable, as it's designed to be used with existing equipment in the space today. And finally, it's flexible because it also allows for older devices to be maintained with secondary control adapters and network control for most modern devices. There are some prerequisites for this control system. You will need Zoom Rooms version 4.6.0 or later for Mac or Windows. Your device will need to be accessible across the LAN or the wireless LAN. And if it's not able to be controlled across the network, you will need an affordable Global Cache iTAC series adapter. We enable the room control setting via the Zoom web portal. Simply navigate to Room Management and Zoom Rooms, and click Edit to the right of the room or group of rooms depending on hierarchy. Navigate to the Devices section and enable room controls. Once this is done, a Create Profile button is generated below, where you can load your JSON configuration. For those needing additional information past what's covered here, the blue Learn More link in this setting will take you to the support page on this subject, containing updated information, additional references, and a sample JSON file to get you started. JSON probably looks like the most complicated part of this process, so let's take a look at what JSON is and how it works to ensure you're comfortable working with it. JSON is JavaScript object notation and is very common on the web. It's usually used to send sets of information between two different systems like a server and a web page. JSON is called self-describing, meaning that it is relatively easy to read and understand what sections are doing inside the file. JSON is distinguished by data in name-value pairs. We'll look at this further in a few slides. And data objects are separated by commas. Curly brackets contain objects, while square brackets contain arrays. Not everyone has programming experience, so we'll step through all of this in more detail now. Here is an example of a JSON argument. You can see various components and multiple lines with lots of different punctuations. We'll break this down into parts to understand it more clearly. As I said earlier, JSON is a name-value based system. So as we look into these highlights, the name is shown in yellow, and it's separated by the colon in blue, and the value for that field or name is John in green. This is easily equated to things like web forms, filling in first name, last name, or email address. You can also see that these elements do employ a double quotation in various places. This notes a string as opposed to numbers or other variables that may exist elsewhere in code. We also talked earlier about objects versus arrays. So here we see the first object, employees. This is shown with the curly brackets at the beginning and end of the argument. The value after the name employees holds additional value objects. Here in the first entry, we have the object John Doe. First name John, last name Doe. But he exists in a list of other people. That list is an array and is noted with square brackets. You can see the whole list or array of employee names is contained inside of this array. In the Zoom native control configuration profiles, you'll find three main sections or objects that need to be defined: adapters, styles, and rules. We'll cover all of these moving forward. We'll start with adapters, one of the most important sections for establishing how we're connecting. We offer three different model names available for this section: the iTAC IP2SL, the iTAC IP2CC, and the generic network adapter. The first two show Global Cache part numbers, but please note on the right that you can also use the Wi-Fi versions of these without needing to change the model name. The generic network adapter would be used for everything else, whether that's a secondary control system, a lighting system, a device that supports direct IP controls. Whatever the case may be, if you can connect to it over the network, you can typically use the generic network adapter. After we set up the model, we need additional information. In the case of the iTAC IP2SL, for example, we'll need the IP address, an optional UUID, And we also need to define ports, or the specifics of that control connection. The ports show exactly how that connection needs to be set up to communicate. We're looking for an ID, or programming reference name, the name, which is the user interface name of the device, settings, in this case setting up the serial connection. The settings for the baud rate on a D10 would be 115200, but should be verified for your unique device. Flow control and parity will generally be set to the settings shown here, but you'll want to confirm this as well. From here, we define the methods. Methods are the actual things that occur and how they're formatted. We can see at the top we have power defined first. This is inside the curly brackets as it's part of this control object. The ID would be power. Again, this ID is a programming reference that can be called in other areas, but is not seen by the user, so you can use whatever ID makes sense to you and others. Then we have the name power, which is capitalized as it's seen as a name by the user. Then the command field is where we'll actually enter the commands that the device needs. And you can see here what we've included in the double quotes is hex, which is pretty common in the AV world, but ASCII is fully supported as well. Double slash plus X for the hex and the hex code after it. And then we define the type as action. You can see I've highlighted action and actions because they do define different user interface styling to fit being one or many commands. The second example shows this where two commands are possible inside of the same parent command. You can see the first two hex symbols, then a percentage sign, followed by hex AA. That percentage sign is pretty important. That sign is a placeholder for the other command segments that feed up from below. These segments are infilled where the percentage sign sits depending on which function is called. It's defined inside of an array, inside the parameters or params field. In this case, we're showing on as 1 and off as 0. So pressing on will send the combined POW1 and off will send the combined POW0. Defining that as type actions allows both of these buttons living on the same line of the interface. This is very easy to read and allows us to define each command separately without a lot of additional type entry and opportunities for errors, and it makes the code much more efficient. Moving on to styles. Styles define how things look. These can define icons for device areas, shown here in green, functions of the devices showing their own icons as well, shown in blue, which in this example would do up and down arrows rather than the words up and down for the volume functions. We can also define the main method if applicable. In the case of a light, that may be power, so it's simply a single area with a power button. And there's also a fourth option shown on the help page for command visibility. This is handy if you want to add comments to a device that are not shown to the user for their use. Why would you want to program in buttons just to hide them again? The rules are where we'll define the automated functions. These items are activated without the user's input and are a powerful way to simplify your Zoom rooms within this system. The rules define based off of event triggers. Today we have events for meeting start and end, mic mute and unmuted, and video started and stopped. As you can see here on the right, we have things like mic mute following the mic status. We've got video started activating some scoop lights that are more appropriate for video calls than task lighting, and the display power to only be on during meetings and off otherwise. You also want to note that some events stack multiple controls. This is a great way to drive a more scene style functionality, rather than just being able to leverage one part of the environmental controls as needed. You can even dump these as prompts to a third-party control system to start macros. That concludes the basics of getting started with Zoom Room native room controls. We look forward to seeing the amazing things you folks will do with these new options, and we'd love to hear your feedback. You can reach out in the Zoom support portal at support.zoom.us under Room Controls and follow our status and blog pages to see when more updates like these are released. I'm Shane Springer, and I appreciate you spending your time with me today. Good luck and have fun.